Okay, so good morning, Dr. Shrikant. Good evening, everyone, and welcome to this sixth day of this week three for this session on hands-on learning with R and Python with Dr. Shrikant. Over to you, Dr. Shrikant. You can wait, you can start. It's up to you. Thank you.
Okay, thank you. I'll just wait for a minute.
Yeah,
Wait.
sure. Thanks.
Okay, so good morning. We will just continue the session from yesterday, where we discussed some of these basic syntax statements in Python and some of the differences between R and Python language. So I'll just go over a few things we discussed yesterday, and then we can continue on some other uh, conditional testing, and then one exercise in Python. So we started with some of these print statements, right? How to print things in R. Then we looked at what are these spaces or indentations, how to create variables. So the variables or data types can be, say, int variables, or it can be string variables. You can assign a value to these variables with your preferred name, and then you can print them uh, passing the variable names. Then, so different variable types can be, say, a string, or it can be just one letter character. Then it can be integer values, or it can be digits or floats. Then we also looked at Boolean testing or Boolean expressions. So if you have, say, two variables called variable A and variable B, and you want to do a test to check if B is greater than A, then you can use an if-else statement, and you can print the string say B is greater than A or B is lesser than A, and then it should produce you this output, or it will produce you a Boolean expression. So it can be true or it can be false. Then we looked into operators. So operators are just the symbols, the special symbols which are used to perform different tasks, and these are same as any of these mathematical symbols. So plus sign is for addition, multiplication is a star sign, subtraction is the negative sign, and so on. And then the last thing which we looked into are the list. So these are different data structures which hold your data. And the simplest or the most easiest to work with data structure is the list. So you can create the list using any of the name of your variable, and then you can just assign your data values to the list in these square brackets. And the list in Python is very flexible, where you can assign strings, integers, floats, everything. It can be assigned in one list. um, then you can use these lists to do task, right? So you can print the elements in this list using a for loop, or you can also print it using just a normal print statement. The difference between a for loop or a for statement in printing is that it is a sequential print, right? So it will check for each position. So position 0, position 1, position 2, and it will do things for for each position. So it's a sequential run, while the normal print statement is where you run everything together, right? So you don't consider the position assignment. You just print what is present in that list. So that's a big difference between a for statement print and a normal print. But this is just one use case, right? So for can be used for many other things, but in this case we have just used to print some elements in a list. Then we will look into, okay, so that's done. So that is where we stopped yesterday. List, how to create list, how to do a few tasks with those list. And then we discussed about arrays, right? So the matrix or the array in Python. So so how do you create an array? So we do know how to create a list, where you just create a variable name, right? And then you just pass the elements of that list in a square bracket, as what we have done here. So fruits is a variable name, and equal to a square bracket, and you pass the elements. In this case it is apple, banana, cherry. So these are different elements which would be present in this list named fruits, right? So this is the most easiest way to create a data structure. But then we also briefly looked into what are these arrays, right? So multi-dimensional arrays. So multi-dimensional arrays, as we briefly looked, they can have like multiple rows, right? So you can have like A, B, C, D rows, and then you can have any of these numbers in these rows. So this is one of the array example, where in this array example you have 4 rows and you have 4 columns, right? So first column is holding the characters, so A, B, C, D. So these are characters or letters which are in column number 1. Then the second column, you have some int values, 1, 2, 4, 6. Third column, again, you have some int values, and fourth column, you again have some int values. So if you want to create a list, you can just do, just if you want to create a list for row 1, then you can say a variable name called row1 is equal to um, square brackets a comma 1 comma 2 comma 3 square bracket close. So that would be your just list on row 1, which will hold a 1 2 3 values, right, or elements. But in this case, we want to create a array. An array is something which should hold more than one row, right? So you should have A 1 2 3, then you should have B 2 5 7, then you should have C 4 8 1, and then you should have D 6 7 9. So you should have 4 rows in one data structure, right? So essentially, what you can do here is you can create the you can create uh, 3 or 4 list elements together, right? So for example, if I want to create a list of row 1, I'll just do row 1 and then square brackets. I'll add my elements in this list for row 1. This would create a list called row 1, and it will have a, it will have 1, it will have 2, it will have 3. But we want to create a array. So array is multi-dimensional. It will hold the entire data frame here, right? So it should have A1 to 3, it should have B257, it should have C, it should have D. So everything should be stored in one structure. So to do that, what you do is you adapt the similar way of using a list, but you just add multiple lists in um, together, right? So you add multiple lists uh, in one list. So I can just do something like this. So I can take my first row, then I can take my second row list 2 5 7. Then I can take my third row list, which is C 481. And then I can take my last row list, which is D679. D679. So you can add multiple lists in one list, right? And that's it. So this would generate an array called as array, right? The name of this array or a multi-dimensional structure is called as array, and then it will hold multiple lists, right? So first list would be for first row, second list would be for second row, third list would be for third row, and fourth list would be for fourth row. So let me just run these on my console and show you what we have. So print, I'll just do print for row 1 first. So you should have those first row elements stored in row 1 variable. And then if I run my array statement here, then I should have print array. Then I should have all the rows stored in one structure. It's called as a multi-dimensional array. If you have more than one rows stored in form of list, right? That's an array. So obviously, working with an array is a little tricky because um, you have more than one row, so you need to assign the positions, right? So if you have just one list, then the position assignment should be position number 0 is A, position number 1 is 1, position number 2 is 2, position number 3 is 3 for row 1. But if you have more than one list, then the position assignment is where you need to mention the row and the column, right? So for example, I want to see what is in the position 0 and 1 cell. It's 1. What in the position of array 0 and 0? It's A. Okay, so you have to provide the reference in terms of the position with respect to row and column. So when I say array 0, 1, it is giving me a value of 1. When I'm saying array of 0 and 0, it gives me a value of A, right? So the first list elements you can select by passing first cell as row and second cell as column, right? So 0 and 0, it means 0 is the first row, or yeah, first list, and second 0 is the first column. When I say 0, 1, it means first row and second column. When I say 0, uh, when I say 0, 0, 2, that means first row and uh, third third column, which is 2. When I say 0, 3, it means first row and fourth column, and so on, right? So the the first cell here is the first list, and the second cell here is the column. Okay, so that is how you select the elements of an array, where you have to specify your row number and column number. Okay, so so this is just a simple example, right? So you can have a complex array, you can have so many lists or so many rows in an array. So but this is just a simple explanation of what is an array and how do you assign the positions for elements in an array, how to extract things from an array. Okay, so I'll just wait here for 1 minute, and if you have any questions, you can ask me now. Okay, so so that's with your two data structures. One is the list and one is the array. It's similar to if R, um, and um, and I guess there is another data structure. So in R, you would have a data frame, a matrix, and a list, right? Um, so a matrix is a little different than a data frame. A data frame is also an array in R when you compare to Python. So there are some differences, but the concept itself is same, right? So array is something where you have more than one rows. List is just one row and multiple columns. So so next thing which we discussed yesterday was, okay, so at this point we are just looking at syntax, but we have not imported any external libraries as in R, or we have we are not using any external functions, right? So so libraries again in Python are like third party tools which we can import in Python, and then you can use any of these functions from those libraries to perform tasks, as we did with the Affy library in microarrays, right? So Affy library, it was developed by someone else, uh, like an Affymetrics company, and then we just imported that library by installing it in R, and then loading the library using a function library Affy, right? So similar to R, in Python also you need to import libraries and then use the functions from those libraries. So some libraries in Python are inbuilt, right? So once you install your Python, then you would have that library installed. So for example, there is one library called import, I guess, math, right? So import math is just an inbuilt library where I just use a function called import space math. Math is the name of library, and it will do some mathematical operations or functions. But I just want to show you how to import things in Python, right? Import space math. For R, you just do library bracket, the name of the library or a package, and then bracket close, right? So that's the difference between R and Python. In Python, you just do import because you want to import a library. In R, you apply a function called library bracket Affy bracket close, right? So that's the difference between import in R and Python. But this is for inbuilt library. And there are many of these inbuilt libraries which you can import. But sometimes again you have to import a library which is not installed in Python. So you would have to install a library and then you would have to import it. Say for example, there's one library called import math. What is it called? Matplotlib. 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 Right, so this is one library which is also very interesting, useful, which can do some of the plotting as we did in R, right? Like scatter plots, box plots, Venn diagrams, and so on. So the name of the library is called as mat, M-A-T, plot, P-L-O-T-L-I-B, matplotlib. Now obviously this is an external library. So if I just hit enter, it will give you this error. So it is giving a traceback error, and it's saying that module not found error. No module name matplotlib, right? Uh, so Python calls these libraries as modules, right? Module, so meaning that library is not found, it's not installed. So it is saying that you first install this library, then you can import it. Now, installation is different for Windows and for Mac, for any of these Python libraries, because in R, at least you have like some similar options where you can go into the like this tab here, file tab, and then you have some install cran options which are similar to Windows and Python. So you can use that, or you can directly copy the code from GitHub or the bioconductor library page, and then you can hit the BIOS install instruction there. But I'll just share what I do in MacBook for installing these Python libraries. Okay, so for Windows it is different, but I'll just share what I do for Mac operating system. So if I want to install any of these libraries, I use a function called pip, right? Pip, right? So pip is a function or a command which would install any of the Python libraries. It can be called as a Python installer. So to install any of these libraries, say for example, I want to install a matplotlib library on my MacBook, then I'll just go on to my terminal window, and on the terminal window, I'll just type in pip Now, PIP installer is sometimes it works for any Python version, um, but uh, they have two versions of PIP, PIP and PIP3, right? So these are two versions of PIP, PIP and PIP3. Say you have a Python version of 2 point something, right? So in my case, I have a Python version of 3.11.1. But if you have a Python version of 2 point something, then you should use a PIP installer, right? And if you have a version of 3 point something, you can use PIP3 installer, right? But I have tested this, and sometimes it does matter, sometimes it does not, because I've tested it with both PIP and PIP3, and it works both the times, right? So it does not matter if you have uh, a Python version 2 point or 3 point. But at times I had an issue with these conflict, right? So just to remember that you can try PIP or PIP3, right? If PIP does not work, try using PIP3. So let me just use PIP here. Let's test to install a library called matplotlib. So I'll just do PIP. I'll do install statement, and the name of the library is matplotlib. Okay, and then I'll just hit enter, and hopefully it should install. Okay, so PIP not found, so I'll just do PIP3. Okay.
Dr. Shrikant, I would like to just add over here while you are installing, or rather, it's already got installed. Yes. So for Windows, it seems what I generally do is that I use pip itself and pip install whatever matplotlib or whatever numpy pandas etc. that I would
Okay.
like to install. I use just pip and it gets like installed. But if you want to upgrade, you can also upgrade also if needed actually.
Okay. So do you run the pip on the CMD?
Yes, yeah, I do it on shell, Windows shell itself. Sometimes I do on Condas also, Anaconda prompt. Then I do Conda, and
Hmm.
yeah.
Okay. Okay, I think that is helpful, because if you have Windows, then you can also run PIP, and then it's just with same instruction, PIP install and the name of the library, and it would I don't know, it maybe take like less than a minute. It's very quick process to install these libraries on shell. So you do that, and then that's the output you get, installing collected packages. But if you have an error, then it will say here, right? It will say in the output that there was some error in install, so it has not successfully installed your library. But for me here, I do not see any of the error, so everything looks good. Uh, you just check the output from this command, and hopefully you should not have any error named there. So mine, I think it's correctly installed. So now if I go back and if I just type again import matplotlib library, then I don't have error now, right? So previously I had this traceback error, no module named matplotlib, but after running a PIP3 install, then I have installed this matplotlib, and I have imported the library called matplotlib. So then I can use and go ahead any of these functions from matplotlib to do plotting, or to use this library in Python. Okay, so try this. Try running matplotlib install on your Windows using PIP, or on your MacBook using PIP or PIP3, and just get familiar with how to install these external libraries, and then how to import them in Python. Uh, all right, so that's with the libraries, and how to install them and how to load them. Should be easy once you know how to do that. You can also, like, if you have any issue, then you can just Google the name of this library, right? So if I have any error, then I'll just Google the error statement here, right? So the error statement here says that module not found error, no module name matplotlib. So if I don't understand the error, then I'll just copy the error output, um, and then just Google it. And the excellent resource to find any of these um, answers on your errors is Stack Overflow, right? So there is a website called uh, I'm sure you know this, right? Stack Overflow. So Stack Overflow is a free platform of discussing all these errors. You can have people posting um, it's like a community forum uh, where these developers they post their questions and the users they answer. And I usually refer this website um, for getting answers to any of these coding question errors or questions, right? So for example, if I have an error this called no module name matplotlib, I'll go in Stack Overflow and I'll just give a search, a general search on Stack Overflow, and you can have some answers to your error. Right? So if I just did a search for module not found, no module name matplotlib, I have like 500 results in Stack Overflow. And then these are different um, discussion threads which have been generated by different users. You can just select one of these threads and you can see that someone has posted that I'm using a Python notebook and I get this same error which we have, no module name matplotlib. I tried to update and reinstall. What should I do? And then you have 9 answers from these other users, right? So other users they suggest things that these things may have worked for them, so you can try, right? So here is something what you have to do. Pip install matplotlib. So you can try this, and then any other user can upvote it and say that okay, this worked for me or this didn't work for me. And so you can just try these different suggestions from these users. This is a very useful community forum. You don't have to register, you just do you don't have to um sign up for any account or anything. So you just do a general search, and without any registration, you can find the answers to your questions. All right, so that's with your libraries. The last thing which I want to discuss today is the
Doctor,
yeah, Dr. Vish.
hello, Dr. Shikant. Good evening. Yeah, I'm sorry, good morning to you there. Okay, I was just wondering, for 1 or 2 minutes, I was a little distracted because, I had to talk with the person here. But no, I just wanted to tell actually one thing before that. While you were demonstrating the installation of the library, okay, you sh showed in the process, you actually showed there is a terminal bar from where we have to actually do that. Now, I'm not able to actually locate that bar uh,
Yeah,
where to
so
do that.
if
Can you
you're
please?
using yeah yeah so if you're using Windows, then the terminal you can get by typing in cmd.
Okay,
If you just so in the search box on your Windows, if you type in cmd, so then you get
right.
your Windows terminal, right? So in that Windows terminal uh you can try pip install matplotlib.
Okay, okay,
Yeah, yeah.
right. Okay, okay, fine. Got it. Yeah.
Yeah.
Thank you.
Okay. All right, so the last thing which we want to discuss today is an exercise of using the basic Python syntax and generating an output, right? So this is a bioinformatics related question where it says that given some string DNA, right? So if you have a string of DNA and DNA should have 4 letters, A, C, G, T, right? Adenine, cytosine, guanine, thymine. So you have these 4 letters and there is a string of DNA. We ask the question, how many times a certain base occur in a DNA string? Okay, so for example, I have a DNA string which looks something like this, right? So you have A, T, G, G, C, A, T, T, A. The question is, in this DNA string, say I want to look at base T or thymine, how many times is that base repeated? Okay, so this is a small string, right? So I can just check T, T, T. So you have 3 times T has been repeated. So T value should be 3. The base T is repeated 3 times. If I just look at base A, adenine base, then A. So A is again repeated 3 times. If I look at cytosine base, cytosine is repeated just 1 time. So C is 1, A is 3, T is 3. Right? So can you write a program, a Python program, which would read this string and it would get you the frequency of the selected base? Okay, so that's the question. The selected base, say I want to select a base called T or thymine. I want to check how many times the thymine base has been repeated or the frequency of thymine base. Then can you write a Python program to do that, right? So just by using basic syntax, right, you don't have to import any of the libraries or any special functions. Just by using the very basic syntax of a for statement and an if statement, we can do that, right? So let me just copy this function here, and I'll just explain you how this works. Okay, so to answer this question, we have to write a function, right? So you have to write a function which will do some task. The task here is counting the specified base frequency. So to write a function, you start with a keyword called def. So def is a keyword and it means definition or a function. So the function name here is count underscore v1. So you can give any function names. So I just chose to give that it is counting something. So let's call it as count underscore v1, right? So df is a keyword stating that anything after this would be called as a function in Python. The next is the function name, and the function name here is count underscore v1. Then in the function name itself, it is taking 2 things. The first thing is the sequence or the DNA, right? So sequence, and the second thing it is taking is which base you want to calculate or count on, right? So let me call this as first element as DNA or just the sequence. And the second thing I want to pass is which base I want to calculate on, which letter I want to calculate on. Okay, the next is I give a colon. Then you have an indentation, right, without a keyword. So it will start with your second word on the second line. Then in DNA, I want to store that in a list, right? So you have these different letters. So it is a string and I want to store each of the letter into a list. So I just do list of DNA and I store it in the same name called DNA. So convert the string into the list of letters. Then I give my for loop. Okay, so for loop, I want to go through each position in that list. Okay, so for C in DNA, for X in DNA, for any letter in DNA, it is just assigning a position. If, say, first position is equal to base is your specified letter. Say in this case, I want to count how many times thymine has been repeated. So base is T. So if the first position in the list is equal to base or say letter T, then you do a +1. Okay, so you do a +1, meaning go to a next position and do a return of that letter or of that count. Okay, so for example, if C is equal to T, which is the base or which is the letter which you want to compare, then this condition satisfied. So increase the position to next position, right? So you started with first position, so you add 1 to that position, so it will now go to second position, and you count it, so you return I. So you count that value because the T has been detected first. So T value is 1. Then it will again go back to the next position. In this case, I would be 1. Then if it is equal to T, and then it will again go back to I is equal to 3. Then if it's again equal to T, then it will go back to I's 4 or fourth position. So let me try to run this and then show you how it works. So to run a definition, you first just copy the entire definition function, and then you run it on your console. So if you don't get any error, that means the Python has registered your definition. So we are good to use your definition. But if you have any error, it will show you that there is some error in this definition or function. So now the function is, you have ran it on your console. So Python knows that there is some function called as count_v1. To run this function on your query, what you do is you just type the function name, which is count_v1 and bracket. So it is asking for a DNA sequence and the base on which you want to check your frequency. So DNA sequence, let me just pass the sample sequence here. And the base you want to count on is letter T, right? Thymine. Okay, so I missed the double quotations here. So I'll just pass everything in double quotation because these are strings. So string, base, and letter. Something like this. Okay, so you get an output called 3. Right? So what it has done is it has checked this string of DNA A T G G C A T T A, and I want to do a match of letter T. So I want to see how many times letter T has been repeated in this sequence. So as we can see, T has been repeated 1, 2, and 3 times. So my function is going to check for the T letter in this sequence. And the steps to do that are, first is you take your DNA sequence, you convert that into list of elements. Then using a for loop, you go to each position in that list, right? So you go at position 0, position 1, position 2, position 3, position 4, 5, 6, 7, 8. Right? So you go through each position, and for each position, you just have to do a match. If the position is equal to base, then you go to a next position and then you add, right? You make a count of that. You keep a count of that match, right? If I see, so first position here is A, so it's not T, so it's 0 count. Then it goes to second position. Now there is a T here, so it will keep a count of 1, and it will move to next position. The next position is G, so no count. Then C, then again G, so no count. Then C, no count. A, no count. Then there is T, there's a count, so 1 plus 1 is 2. Then it goes to next position, again is T, then it will add another one, so third count is 3. Then it will go to next position is A, so again 0 count, so 1, 2, 3, 3 counts, so 3 is the output from your function. So this is one of the ways of doing this task, but obviously there are many different ways. It depends upon how much what is the complexity of your task, right? So this is a simple small DNA sequence, but you can have a DNA sequence of like, I don't know, like 100,000 bases. So to do this process, it will take some time, right? So you have to go through each position. So the complexity is little higher. So there are other ways to do this, right? You can divide the DNA into two halves. So there are some algorithms which you can use. So split and merge, and few other things. So decrease the runtime, right? But this is a very basic step of using basic syntax. You are not importing any special library functions in this definition or in this function. But there are also other external libraries which can do this search, and those will be quicker. But everything depends upon how much complex your problem is, how much data you want to search upon, how quickly you want to do this process, and how much computing resources do you have. Now, obviously, if you have like 1 million of these bases, for example, to do this on your computer, it is going to take significantly like long time, amount of time to do the search. So you can run it on GPU, right? So GPU would accelerate this process. You can have multiple cores on CPU. You can just keep it running on Colab or any of the cloud resources. Um, or Yeah, so these are few things you can do with writing the functions and performing tasks. And this question I chose because this is related to bioinformatics, where you are searching a DNA or an RNA sequence, right? Okay, so I hope this gives you some idea on the basics of Python and R. Um, I feel like this is, I guess, is enough for you to practice. Everything is on my Git repository, Summer School, and I also have your users, right? I can also access your repository. So if you have any questions, right, you can just email me, and I can look into your repository. If you have any code questions, I can give you some suggestions in terms of any of these bioinformatics pipelines. And or you can also know Dr. Lahiri. Dr. Lahiri and I, we collaborate on some of the projects and papers. So if you are interested in working with him or me or us, then you can let him know. So I guess that's all I have for these 2 weeks. And So we have like 10 more minutes. And if you have any questions or any advice, suggestions, feel free to give them now. So I'm done. Thank you. Dr. Larry, are you there?
Yeah, I'm here. So yeah, the participants can ask questions if they want to. And Dr. Shrikant is here for any such few quick questions. If detailed, they can be sent later to the group, to the forum, or personally to him as well. Uh, yeah, there is no such doubts or questions, it seems. The whole, there's a pin drop silence over here. So we can call it off, I think, Dr. Shrikant, and thank you for this 2 weeks effort for uh, making us a little bit enlightened on R and Python. It would have been better had there been more, but that's fine. Thank you everyone for participating for today's session, and we all will meet again on Sunday for the next set
Monday,
of
right?
sessions. On Monday, yes, for the next set of sessions on protein and antibody engineering, etc., by Dr. Anand Narayanan.
Yeah. So he did, I think he was present yesterday, right?
All right, he was
So
yesterday.
he did mention some of his topics which he'll be discussing. So I guess he'll be joining the same time.
Yes.
Yeah. And
Okay.
yeah,
I
Yeah,
hope there's nothing
I
else.
think
Yeah,
really thanks to you,
we
Dr.
can call.
Shrikant. Okay, whatever we could gather in this 2 weeks, I think it was really helpful, not only for